This shows 12 hours at the famous Bay of Fundy in Nova Scotia, Canada. It's the biggest tide change in the world. But what force could move such a massive body of water?
This is a map of tidal amplitude, which is the difference between the low and the high tide in a given place. So what that means is that the low tide might be a meter below sea level, and the high tide might be a meter above sea level, and that would be a tidal amplitude of 2 meters, which is considered very high. And those high tidal amplitudes are here in red. So this is where the difference between the low tide and the high tide is the greatest. What you'll notice with this is that there are places where the tidal amplitude is very, very low. It's actually 0. And those are the places here in pink. In these places, there is no tide. Low tide is the same as high tide. What that translates to is 0 tidal amplitude. So every place in pink has 0 tide. Now, the places where there is no tide, these are called amphidromic points. I will call them tidal nodes because that's the more commoner term for them. And they're here. And these are the places, these points, that there is no tide. Literally no tide at all. And there's tons of them all over this map. There's these ones in the center of the oceans, which are quite easy to see. But if you look closely at this map of amphidromic points, tidal nodes, you'll see there's also a number of much smaller ones that operate in smaller regions. I'm going to circle these 3. Look, there's 3 tidal nodes. These are areas, again, with no tide, where the water is still all year long, all day long, all week long, no tide. Here's another one here. Here's another one here. You can see 3 in here. You start seeing them when you look, you start seeing them all over the place here. See, there's actually 3 up here in Upper Canada. Now, the greatest density of these that I've seen is in the Polar Sea. Now, this is a polar projection map. This is a favorite by flat earthers. And you can see how many of these nodes are in the Arctic Sea. This is the Arctic Sea up here, the North Polar Sea. You can see all the nodes in here. I'm just circling them all. These are places with no tide. This is just a zoom in on that so you can see. It's almost fractal how this looks because you've got all these little nodes here and then you've also got all big nodes all in the sea. Oh, that's where the purples are. These big tidal nodes. These seem to be the center of what's going on with the tides. This is a better chart of the Polar Sea. So this is, again, a North Polar projection. I've placed a big X on the North Pole. And you can see even more in here. It seems almost like there's too many to count. Like there's areas where they're just extremely dense, these tidal nodes. So I think there's even some on these islands. These don't have to be underwater, and I'll talk about that later as well. Look at this. It seems like there's 3 in a row in here. All these tiny little tidal nodes. It's almost fractal how this seems to work. There's 2 here. This is Hudson's Bay in Canada, and I'm going to talk about that later. But first, this is the Mediterranean. There's also tidal nodes in the Mediterranean. It's not as dense, maybe, as in the Polar Sea. This is another one that's on land, actually. And I think it looks like there's one here. You can see this is Cyprus, so that's sort of how the Mediterranean here is aligned. This is the North Sea near the United Kingdom, and you can see these 2 tidal nodes here, as well as a tidal node which they've clearly marked on Sweden, or Norway. That would be in Norway. I've also got this side by side with an actual animation. Now, what's nice about this animation, it shows tides. It doesn't just show tidal amplitude. It shows tides in real time. And you can see how high these tides are relatively. These are these huge 2 or 3 meter tides that are all rushing up through this English Channel here. And yet you do have a tidal node very close into here. So you've got these massive tides, but you actually have a tidal node around here. Now this model doesn't show the tidal nodes amazing because you can see some of the tide go in through here. But it's pretty good here where you can see the tide's up on this side, then it's up on this side. It's up on this side, and then it's up on this side. And the tidal node itself, the sea level never changes. So this is a better map, a more detailed map of the tidal nodes, and it shows another tidal node with this arrow around New Zealand. So New Zealand's another example of a tidal node that's not under the ocean, but still seems to affect the tides. And what I mean by affect the tides is you can see this arrow. Tides revolve around tidal nodes. So a high tide seems to be a bulge of water that will revolve in a certain direction, and it looks like the direction is different in these different nodes. There's clockwise and there's anti-clockwise, but it has nothing to do with the equator, because this one you can see here is clockwise. This one you can see is counterclockwise. This one you can see is also clockwise, and this one here is counterclockwise, and there's really no pattern to whether it's going to be clockwise or counterclockwise. This shows a live animation of the tides, and you can see exactly what I mean when I say that tides revolve around the nodes. So I told you about those two nodes up here in Hudson's Bay. You can see the high tide in red revolving around the coast of Hudson's Bay. You can also see this in New Zealand, which I told you was an on-land tidal node. You can see this high tide in red spinning around New Zealand, and the low tide in blue, some negative tide, also spinning around New Zealand, and they almost look like magnetic fields in the way that this is pictured here around New Zealand. So this is Hudson's Bay again. This is a different tidal animation, and you can see how these tides seem to revolve around Hudson's Bay. And again, there are tidal nodes, two tidal nodes here in the center of Hudson's Bay that show no tidal movement whatsoever, while you have huge tidal movement around these shores. And this, again, is New Zealand, and this shows those tides revolving around New Zealand. If we go back to this earlier map, you can see that there are all those tidal nodes there at the base of South America, just like you may expect if these tidal nodes were what's creating these tides, because you've got a high density of these tides, so you're actually moving a great deal of water against this continent of South America, which is why you've got this black here. This is, I don't know how tall the tidal amplitude is right here, but it's very, very high. I think in some places the amplitude is as much as 4 meters. So this could be a full 4 meters here at in Argentina.